Alabama STEM Explorers is made possible by the generous support of Hudson Alpha Institute for Biotechnology, Southern Research, solving the world's hardest problems, the Holly Family Foundation, Alabama Works, Alabama STEM Council, Alabama Mathematics, Science, Technology, and Engineering Coalition, Alabama Math, Science, and Technology Initiative.
Have you ever wondered how water gets here and where it comes from? I think I know someone who could help us out. Come on.
Thanks for joining us on today's episode of Alabama STEM Explorers. I'm Kathryn, and I am here with my friend Cruz at American Cast Iron Pipe Company, or ACIPCO, and it's located right here in the magic city of Birmingham, Alabama. It's a really, really cool place, and super old too, right? So ACIPCO has been here for almost 120 years. So they were founded in 1905. Pretty crazy. And we are joined today with our friend Lindsay, who is a manufacturing engineer at ACIPCO. And Lindsay, Cruz and I were talking about the network of underground pipes that allows water to flow to our businesses and our homes. But we were also talking about how it's not necessarily the same types of pipes that we might see in like underneath the sink in a bathroom, but that the pipes have to be made in a way to withstand different environmental pressures and to last a long time. Can you tell us a little bit more about how this whole process works?
Absolutely, that's a great question. So when you turn on your water faucet at home, your water has to get there somehow. So what happens is it flows through a series of pipe, many of which are made out of ductile iron. Now we can't melt ductile iron in a conference room. So instead, I will show you some of the heat treatment principles through the melting of chocolate. Would you like to help me with that?
Yeah.
That sounds delicious.
Yeah.
So this is an example of some of our ductile iron pipe. Normally we sell these in a 20-foot length, but this is something you can hold in your hands.
Okay.
Now then, it's called ductile iron pipe for a reason, and that is because the property that is most known for is its ductility. What that means is that if you hit it with a hammer or something, it's not going to shatter like glass will.
So it's very heavy.
It is very heavy, and they get even heavier as they get bigger. So when we cool our pipe very, very quickly, it makes the material very brittle. So if we were to drop it, it would shatter like glass. And we don't want that in our pipe. We don't want our pipe to break while it's in use. So what we do is a process called heat treatment. We put it through a series of ovens that will change the microstructure of the pipe to give us the mechanical properties that we need. So the principles of heat treating can be applied to many different types of materials. In this case, I'm going to show you what happens if we quickly solidify some chocolate or if we put it through a process called tempering. So for starters, let's go ahead and start melting some chocolate. If you could you grab some of the semi-sweet chocolate and go ahead and pour it into the pan.
Just want me to grab some?
And just grab it in the cup. Oh, like you're going to need more than that.
Yeah.
Fill it like halfway full. All right, that's good to start with.
Okay.
So what we'll do, we don't want to scorch the chocolate. So what we have here is a spatula. It's a really neat spatula. It actually measures the temperature as you're stirring. There's a thermometer inside. So I'm going to hand this to you, and if you can just stir the chocolate to keep it from scorching on the bottom. All right, so as we stir this, we're aiming to get it to a temperature above 115 degrees Fahrenheit and below 120 degrees Fahrenheit. What that's going to allow us to do is make sure we've melted all of the crystal structures in there. But if we get it over 120 degrees, we risk scorching it, and nobody wants to eat scorched chocolate.
Yeah.
Now we've got it right at the temperature we need it, so we're going to go ahead and pour it into a mold that is inside of a tray of ice. This is going to cool it very, very quickly, and then we'll see what kind of mechanical properties we get from it.
Okay.
You can push it out with the spatula a little bit too.
Oh.
And don't worry about having it be perfect. We'll clean it up a little bit. as that cools and as that solidifies, I'm going to teach you how to temper the chocolate. What that's going to do is it's going to help us get the microstructure we want to get that shiny, snappy, delicious chocolate everyone loves to eat. So the way we're going to do that is we're going to melt a little bit more chocolate. Let's go ahead and get that going.
Okay.
There you go. And we're going to slowly cool it. Once it gets to that 115 degrees or so, we're going to take the pot off the heat. And we're going to start adding some more of these chocolates to it, because this chocolate's actually already in the form we want, but it's pellets instead of squares.
Yes.
And what that's going to do is it's going to help encourage the crystal structure that we want to form. We're going to cool it down until it gets to just below 86 degrees Fahrenheit. Doing that, we're going to have a couple different microstructures of chocolate inside, but we only want to have one of them. So after we've cooled it down to 86 degrees, we're going to heat it back up to just over 86 degrees Fahrenheit, and we're going to hold it there for a few minutes, and that's going to encourage just one type of chocolate to form. The other phases of chocolate won't form. Once we've gotten it to 86, 87 degrees, we'll hold it for just a minute, and then we're going to pour it into these molds and let it cool at room temperature until it's solid.
Okay, you're good?
All right, so what we're going to do now is we're going to carefully cool this chocolate by setting it on this hot pad, and then we're going to add some of these chocolate pellets until it gets down to below 86 degrees Fahrenheit. After that, we're going to heat it back up for a minute, and we're going to pour it in the molds. So let's add some more chocolate and just keep stirring. Now that we've got it to the 85 degrees that we need, we're going to put it back over the heat. And I'm going to stay on this side of you, but just keep stirring it. And we're going to heat it back up until it's over 86. I usually aim for about 88 to 89 degrees Fahrenheit.
Okay.
All right, now that we've got the chocolate nice and smooth, and we've got it in the temperature range that we need, we're going to have Cruz come over here, and we're going to have you pour it in the brown mold, and any extra chocolate you have, we'll put in the yellow mold.
Okay.
And I'm going to stay over here out of your way.
Okay.
All right, so we've now had a chance to let the chocolate fully solidify and come down to room temperature, and actually this one's a little bit cooler. Over here we've got the first chocolate we made that was not tempered, and then these two trays have the tempered chocolate in them. What we're gonna see here is we're gonna give Cruz the opportunity to pick up a square and try to break it, and we're gonna see what the difference is between the not tempered and the tempered chocolate.
Okay.
So go ahead and grab a square, a rectangle of the not tempered chocolate,
Okay.
and just see what happens when you snap it. There you go. That's okay.
Okay, there you go.
All right, you can see it's already started melting in your hands. That's because there's several different phases of chocolate inside of it, and some of those phases melt at really low temperatures, and that is why your hands are starting to melt it. Now let's see what happens if you use the tempered chocolate. Pick a square, any square. You can see
Looks
there's
nice.
a difference. It does look nice. You did a really good job of that. You can see there's a difference in the color. It's a little bit shinier and a little bit darker. Let's see what happens when you break it. It just came apart real easy,
Yes,
snapped
it-
real nicely.
Yeah. It was a little bit bendy. It was when I tried to break it. It was bending, but like once I bent it too much, it was broke. So.
Nice. Is it melting in your hands like the other one was?
No, not really.
Awesome. Now then, I've heard that the two taste different. So do you want to try eating a bite
yeah.
of one and then eating a bite of the other? For science, purely for science.
Okay.
And just tell me, do they taste different to you? Slight difference? I don't know about
Slight difference.
Nice. All right.
But this one's better, right here.
It actually, yeah, so this was tempered properly, and they say that this particular type of tempering is the most delicious and the prettiest chocolate.
So how does this relate to a metal pipe?
So the way this relates to metal pipe is what we've done here is we did a heat treatment. We controlled the temperature in order to get the desired mechanical properties and to get it that nice shiny look. We do the same thing with our pipe. We will heat treat it, we'll control the temperature in certain ways to change the microstructure and give us the mechanical properties that we need to make the pipe last for hundreds of years underground.
Yeah, that's really cool.
It really is.
Yeah, thanks for teaching me this.
Thanks for joining me.
My job every day here at American is to make sure that when the product leaves out of the gate, that we're producing top quality. Being in quality assurance, we are the last line of defense. So the company is dependent on our eyes to make sure that we are producing top quality to our customers so that our customers will be pleased and the company is doing a great job in making sure they get great product. The technology that we use here on a daily basis here in the quality assurance department, we use dials, we use pit gauges, we use all sorts of tools to make sure that the pipe is really in its tolerance. And also, other than that, we put it into our computer system. We have a system here called Dazzler, where we also have to be tech savvy in the computer area, where we go and put information in the computer to make sure it's updated where the higher management, upper management could see exactly what's going on, and making sure we have a great account of all the things that we find out in the field, and make sure we put it in a data system so that the upper management can have knowledge of it. I would say to a young person here at ACIPCO who would like to be in this industry is that it's a great industry. I started off 20 years ago on a shop prep crew, and now I'm in the quality assurance department, and it's a great opportunity, and it provides great living for your family, great opportunities to do service in the community, and it also teaches you how to value life and not only be safe at work, but also to carry safety to your home. What I love most about working here at American is the way the company take care of its employees, and the way the company values its customers, and the way the company values its community.
Hi, I've got my friend Lindsay McCall here to help me. He's another manufacturing engineer here at American Cast Iron Pipe Company, also known as ACIPCO. He's going to be helping me do the actual demonstration, and I'm going to talk through what's happening. So what we're doing now is we're going to be melting a metal called tin. It's got a very low melting point. It melts at 450 degrees Fahrenheit. And to show you an example of tin, we've actually got some castings that we've made before. Can you show us what those look like, Cruz?
Yes, I can.
So this is a casting. It's something that we melted the metal, we poured it into a mold, and it came out like this. And a really nice thing about tin and all of your metals is that they're incredibly recyclable. So what we'll do is we'll have Cruz carefully set that in the pot, and we're gonna let it melt. And we're gonna do that with the other piece as well. Just don't touch the pot. And there's another piece if you wanna set that one in. And we're gonna give that a minute to melt, and Lindsay can probably add a few more. It's already starting to melt a little bit. And like I said, this melts at 450 degrees Fahrenheit, so theoretically, you could actually melt this in your oven at home. But don't do that. Just because you can doesn't mean that you should. So after this melts, we're gonna have Lindsay pour it into these molds. And these molds are two parts. So we've got two molds here. And they're made of two different types of materials. The first part is aluminum, and the second part is tile. It's a ceramic tile. The reason that we are able to pour this tin into this aluminum and ceramic tile mold is because the melting temperatures for these two materials are much higher than the melting point for tin. Now we've got the tin nice and molten. It is now fully liquid, but you'll see there's this film on top, and it's kind of ugly. We don't want to have that in our final casting. So what I'm going to have Cruz do is put on one of these gloves for safety, and then we're going to have you use this spoon once you've got that on. And we're just going to have you carefully skim that oxide layer off of the top.
Wow.
So much shinier underneath it. And then just grab whatever you can out of the bottom and we'll set it on the tray. After that, Lindsay is going to use a spoon, and I'm going to get out of his way, and he's going to pour it into these molds. All right, that looks good.
Mm-hmm.
Safety is always a priority in any foundry. That's why we've got Lindsay and Cruz wearing personal protective equipment, also called PPE. Beautiful. All right, as that cools down and solidifies, I'm gonna get my friend Lindsay here to pick up this large, very long piece of tin. One of the really neat properties of tin, it's not something that's common in all metals, is that when you bend it, it actually makes a sound. It's very quiet, so I hope you're able to hear that pretty well. That is something that's called tin cry. Now, it doesn't sound like a baby crying or anything like that, but that is what the metallurgists of the old days called it, so that's what we still call it. This should only take another minute or so to solidify and cool off. And Lindsay, if you want to, since we have a lot of extra metal here, if you want to go ahead and pour the rest of it into this mold we've got, I'll get out of the way. Beautiful. So one of the uses of tin, it's not an everyday common metal that you'll see in use. As you noticed, it was very easy, well, relatively easy for Lindsay to bend it. It's very soft, very pliable. So it's not good for structural uses, but it can be used to help prevent corrosion. So other metals that need to be protected from corrosion can provide the support, and then we coat it with tin, and that protects it from any corrosion. All right, so what we're gonna do is I'm gonna step back for a second, and Lindsay is gonna take our first mold apart. He's gonna pull the first casting out. All right, Cruz, you wanna show it off for the camera? So as you can see, it looks like there's a little bit of the tin that came out. It's outside of the part that we actually want to use. So this is where we'll let Cruz start joining in on it. And we are going to use these snips, and by we I mean him. Cruz, you're going to use these snips, and I just want you to very carefully, you see that thin flashing on the outside of it?
Right here?
Cut about right there.
Okay.
And just cut through it. very, very carefully.
So just, where do you want me to cut?
Cut right where it connects to this big ugly lump.
So just right here.
And just cut through the whole thing. You just want to disconnect it from the big part.
Okay, there we go. Just gonna try and get all that.
And if we need Lindsay to help, we can do that. Oh, you got it. Nicely done. And just grab that and cut the flashing off the outside,
Okay.
and you'll have a coin. Get chocolate on the hole punch. Clean.
Then the last bit should be right here.
As you can see, this is a very, very soft metal. It's relatively easy to cut through. And whenever you've got it looking the way you want it to look, we'll get Lindsay to punch a hole through it, and we'll put some thread through it in a minute. Well done.
Yep.
All you have to do is put a string through it or a chain, and you'll have your very own necklace. Do you have any questions about the process?
No, I think it was all pretty clear.
What I do every day is for my division, we make steel pipe for oil and gas transmission. So my role in the department is I monitor the lab testing to make sure that the pipe adhere to the API requirements or the customer requirements. I also troubleshoot problems for the lab and our line inspectors if they have any problems. One of my other roles is to review technical specifications to ensure that ACIPCO has the capability to meet the customer requirements, and if not, suggest exceptions to the customer specification. Over the last 15 years here, when I first got here, we had just started a system as far as inputting the data into a central database. And so now my job is a lot more data intensive than it was before. With everything, we can tie a lot of things together that was more difficult 15 years ago. A lot of the testing equipment has improved, whereas we used to have to hand enter in some of the test results. Now a lot of those are automatically fed from the computer to the system. We make water, wastewater, oil and gas pipe. Anything we do through the course of the day, whether it is turn on your faucets to get your water, all the way to getting your gasoline, heating your homes, all those things use pipe that we produce. So our industry has been here for over 100 years, and it should be needed for many more. If someone wanted to work here for engineering, what I'd tell them is you're gonna get a lot of different projects. Things are really broad starting out, but as you learn more and grow more in the job, you kind of find your niche where you fit in and where you can contribute to the company.
Hello, my name's Cohen, and what causes my brain to freeze after drinking something cold?
I scream, you scream. We all scream for brain freeze? No, we don't scream for brain freeze. Brain freeze may start when a very cold substance hits the roof of the mouth or back of the throat and stimulates blood vessels and nerves in these temp-sensitive areas. The sharp headache sensation we often feel after eating or drinking something really cold is caused by the cooling of the capillaries of the sinuses, which results in vasoconstriction, a narrowing of the blood vessels. Here's a tip. A quick rewarming of those capillaries by a warm stimulus such as the air will result in a widening of the blood vessels, hopefully alleviating the pain.
Thanks for watching Alabama STEM Explorers. If you missed anything or you want to watch something again, you can check out our website at alabamastemexplorers.org. Maybe you have a question we could answer here on the show, and you might grab a cool t-shirt. Feel free to send us a video question or an email on our website, alabamastemexplorers.org. Thanks again for watching. We'll be back next week.
Alabama STEM Explorers is made possible by the generous support of Hudson Alpha Institute for Biotechnology, translating the power of genomics into real-world results. Southern Research, solving the world's hardest problems. The Hawley Family Foundation, established to honor the legacy of Brigadier General Everett Hawley and his parents, Evelyn and Fred Hawley, champions of servant leadership. Alabama Works, a network of interconnected providers connecting business and industry needs to a highly skilled and trained workforce. Alabama STEM Council, dedicated to improving STEM education, career awareness, and workforce development across Alabama. Alabama Mathematics, Science, Technology, and Engineering Coalition for Education, advocating for exceptional STEM education in Alabama. Alabama Math, Science, and Technology Initiative, the Alabama Department of Education's initiative to improve math and science teaching statewide.